Welcome, this is Professor Bright, and we are going to start our first chapter looking at the coordinate plane, circles, lines, and actually inequalities too. And they're just kind of a type of line. At the beginning of every section that we look at in the course, I'm going to make a cover page to the notes that I produce that articulate the learning target, and then to get to that target, there are certain steps that we need to go through. So those are detailed as well, and the videos that you'll need to watch are listed there as well. The idea is by me communicating this information, this is me telling you as the viewer, the student, etc., this is what you need to know for this section. So for this section, you need to know how to use the coordinate plane to make and investigate lines and circles and solve linear equalities and represent their solutions in interval notation. If you can look at that and say, yes, I can do that with complete confidence, you will be ready for a test. If you are a little unsure, maybe look at these learning steps to kind of break it down to see if you know where you might be needing more help. Okay, and let's have a conversation. Alas, here we go. We are going to look at the first three formulas that we are going to need in this course. Okay, so to begin, in our work in this course, we're going to look at representing mathematical ideas in four ways. We're going to look at representing them with words, symbols, pictures, and tables. Okay, we're going to talk about these as the four forms of a function. Okay, more on that in a little bit, but we want to make sure that we have a common method for the graphical approach, and that's when we're going to primarily work in the Cartesian coordinate plane. Okay, we probably have come across this in our previous studies in mathematics, but the idea is that with a coordinate plane, you have two axes and they intersect at their zeros. So you can imagine one axis is horizontal, this is 0, so you can imagine this is actually a number line. We would maybe use our first variable, typically represented as x, to go horizontally, so we would say positives are over on the right side, -1 and -2. Negatives are over to the left. Okay, so that would be one axis. Then we would intersect this with a second axis in a perpendicular manner so that its 0 hits at the 0 of the x-axis. So this would be also a 0, and then going vertically upwards would be positive numbers, and going vertically downwards would be negative numbers, so -1, -2, -3, and so on. Okay, and this we would call a y-axis. Okay, when we make graphs too, the other thing that we should always include are arrows on the tips of the axes, because these things are going to continue forever and ever and ever. Okay, so make sure to include those. Now, this is fine and dandy, but typically when we use number lines, we're interested in points, right? The only thing though is we have two axes, right? So when we talk about a point here, we need to specify a point with two numbers, an x value and a y value. So for instance, we could be talking about the point 2, -1. And what we would do to locate that point would be progress 2 units in the x direction and then 1 unit down in the y direction. So 2 units in the x and then 1 unit down in the y, so this would be the point 2 minus 1. Okay, and so you can kind of see I trace this out. And again, this we may be super familiar with. But what we do with this is when we use a series of points, we talk about the series of points as being a graph. We might have an equation that we're typically working with, but whatever we get as a result of plotting all sorts of different points, that is the graph of an equation. Okay, so for instance, when we are working with the graph of y equals x squared minus 4, well, we have to get a series of x and y values, okay? And to do that, we might rely on just generating a table of values. So we make a little chart. And to do this, we want to find the values of y. That means we need to pick or provide values of x. So I typically just like doing -2, -1, 0, 1, and 2. You get to pick which x values you put in. And so now I would substitute each of these through here. So -2 squared minus 4. Okay, so that's 4 minus 4 is 0. Okay, so that's the end result of that. -1 squared minus 4 would be 1. We square a negative, that's always positive, minus 4, we get minus 3. Okay, put in 0. 0 squared minus 4, also known as 0 minus 4, also known as minus 4. Okay, and I'm just going to provide the other values here so that we can move along. Okay, so now what I'm going to do is I'm going to plot each of these points. Okay, so in all, I need to go, let's see, 2 units in the x, 2 each way, 4 units down in the y. Okay, and I'm going to plot these points in green. So I'm going to go 2 units to the left in x, -2, and then 0 for the y, -1 in the x, -3 in the y, 0 in the x, -4 in the y, -1, -3, and 2, 0. Now, another nice practice I find is that if your drawing isn't super precise, label the points, okay? That way there's absolutely no confusion, okay? We can't all be the world's best artists. 1, -3, and 2, 0, okay? And so these are just some representative points. When we talk about the graph, we would actually connect all points that we produce and could be produced, okay? And that would be the graph of this equation, y is equal to x squared minus 4, okay? So there we go, okay? If you wanted to, there is a handy website, desmos.com, okay? And then on there you have to click on calculator, but it's a nice visualizing tool for equations. So if you type in y equals x squared and then minus 4, you can see it produces the same idea that we had with just a little bit more precision. So you can see we get our point, and if you click and kind of hold along here, you can see the values pop up. So that's 1 minus 3, 0 minus 4, 1, if we can get right on it, 1, -1, and it's going to be a little hard to locate. But all the points that we produced on the graph there are on here as well. Okay. Now, another thing that we really care about when we're working with the coordinate plane are things known as geodesics. And geodesics are length minimizing curves. So in other words, what is the minimum distance between 2 points, for instance? Okay, so let's just take a look and imagine. So I have a point here. I'm going to give it general coordinates x1, y1. And maybe I'll put that down here, x1, comma, y1. And then we have x2, y2. We have another point. We have a point up here. Something like that. x2, comma, y2. Okay. Now, how do we find the minimum distance between them? Well, minimum distance would be a straight line, right? It'd be this straight line, and I'm going to give it a name of D. Okay. Well, we want to find D. Okay. So that is D. Okay. How much is D? Well, this is where we might need to think a little bit, but if we investigate, right, we can imagine that the D I get from one point to the other point by going or over to the right and up some amount. How much do I go over? Well, this would be, say, oops, let's say this is A and this is B. Okay, so I can get D by actually using the Pythagorean theorem, D squared, because this is a right triangle. Okay, those are perpendicular. So in a right triangle, D squared would equal A squared plus B squared. Okay, and now specifically, how much is A? Well, A would be the difference in the x's. Okay, so this is x2 minus x1 all squared. That's how much A is. And then B would be the difference in the y's. So y2 minus y1 all squared. And this is still equal to d squared, okay? Notice though that I just want d, I don't want the squared. So what do I have to do? I have to introduce a square root, okay? And technically, so if I do d, whenever I introduce a square root, I need the plus and minus, okay? X2 minus x1 all squared plus y2 minus y1 all squared, okay? So when you introduce a square root, you need the plus and minus. However, when we are doing a distance can never be negative, so we just go with the positive, okay? So we get that handy-dandy formula, okay? So again, just to summarize, we found the distance formula by making use of the Pythagorean theorem, okay? So make sure to get the distance formula in your notes. Pythagorean theorem, it's nice, neat. We won't use it in this course. Pre-calc 2, you'll use it all the time, okay? Another formula that you can find that you could use too is the midpoint formula. So if you wanted to find, say, a point, and I'll put it in blue here, that's halfway between here. This would be, maybe call it M for midpoint. To find that midpoint, it's the average, right? So these bars, X bar, Y bar, that is just point M. And how do you find an average? Well, you add them up and divide by 2. That's all a midpoint is, okay? Add the X's up, divide by 2. Add the Y's up, divide by 2, you got the midpoint, okay? So those are our 3 formulas for this video, okay? Now we're going to conclude with a quick example. Okay, so we have some points. Okay, if it helps you to plot them, you can draw a little sketch. I always encourage a little picture. So -2, +1, we're here, and then 7, 1, 2, 3, 4, 5, 6, 7, and then 5, 1, 2, 3, 4, 5. So something like that. Okay, so I'm wondering how much D is here, and then also what the point in that is equidistant from each of the 2 points, also known as the midpoint. Okay, that's going to be equal from both sides. Okay, so I want to find those 2 things. All right, let's find the distance. Okay, distance is the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. Okay, now the real question is, okay, I should label these -2 -2 1 and 7 5. Which one's x2 and which one's x2 and x1? The answer is, it doesn't matter. You pick, okay? I'm gonna just use the convention that the left one is the 1s and the right point is the 2s. So I'm gonna do, the x2 would be 7. x1 would be -2 squared, and then plus y2 would be 5 minus 1 squared. Okay, and then so I get square root of 9 squared plus 4 squared. Let's see, that is square root of 81 plus 16, also known as the square root of 97. Can't do anything with that. Okay, we're going to leave it like that. We're not going to use decimals unless directed to do so. Okay, and then the second thing we need to do, so that's part A, and part B would be finding x bar, y bar, our midpoint. Okay, so this one is where I would add the x coordinates, so 7 plus -2, and divide that result by 2, and then do 5 plus 1 divided by 2. Okay, so let's see, 7 plus -2 is positive 5 over 2, comma, 5 plus 1 is 6 over 2. Okay, and I'm going to leave this as 5 over 2. 6 over 2 reduces to 3, and that is going to be my midpoint. Okay, so again, we love fractions. Yeah, I know you're probably like, no, we don't. We're going to love fractions because we're going to work with them all the time. And we will see a bunch of weird numbers like square root of 97. Work with it as best as you can, simplify it, but do not report decimal answers unless directed to do so.